Number 8. A solution is prepared by mixing 1 gram of ethanol. 1 gram of ethanol, all right. And so we'll do that. Gives you what it is. With 100 grams of water to give a final volume of 101 liters. Okay. Calculate the molarity, mass percent, mole fraction, and molality. Holy moly, we got 4. 1, 2, 3, 4 calculations to do. All right. Well, let's just start with molarity. So for the first part, molarity, I need moles of ethanol per liter. Total volume, right? Okay, so we have 1 gram. Right? CH3, CH2OH. Well, we know that 1 mole of CH3, CH2OH. Well, we have molar mass, 12.01 plus, and I'll write that down. We're just going to write it down. So we have 12.01, and I have 2 carbons. We have 3, 5, 6 hydrogens, and 1 oxygen. So that molar mass is 4608. So now we have our moles of ethanol, which is 0.0217. All right, I think that's what it is. 1 divided by. All right, so now we can calculate the molarity. So the molarity would be 0.0217 moles of ethanol all over 101 milliliters, which is the same thing as 101 times 10 to negative third liters, or 0.101 liters, however you want to convert it. Right. And I get 0.215, I believe. Oh. 0, like that. There we go. 0.215 molar CH3, CH2OH. So there's the answer to number 1. All right, number 2. Moving on. What are we looking for? Mass percent. So the mass percent of CH3, CH2OH, what is that? That's going to be our grams of CH3, CH2OH. All of our grams of CH3, CH2OH, ethanol, and grams of water times 100%. So I think we can do that. Grams of ethanol, 1. Grams of water, 100. All right, because we have 1 gram of ethanol from the problem and 100 grams of water. So we'd have 1 divided by 101 times 100 is what? 0.99%. I have 3 sig figs, so 0.990%. All right. Oh, no, we want to highlight. So there's the answer to number 2. 3, mole fraction. Well, we have moles of everything, right? So the mole fraction of CH3CH2OH, it would be moles of ethanol over moles of ethanol and our moles of water. So our moles of ethanol, already calculated, was 0.0217 moles. Moles of water. Well, I don't have moles of water. I have grams of water. So here we go. 100 grams H2O. There. 18.02 grams of water is 1 mole. So that gives me 5.56 moles of water. And so we do this, right? You get the 0.0217 divided by the 0.0217 plus the 5.56. I get 0.00389. That's what I get for 3 sig figs. All right. And one more, I think, right? Molality. Molality. All right, so number 4, finally. Last part of this 4-part problem. Little m. All right, little m would be moles. Oh, our moles of ethanol. And our kilograms of water. I think we can do this because we know how many moles of ethanol we have. It's 0.0217 moles. Kilograms of water. Well, I have 100 grams, which means, right, if I were to convert that, just do it out just in case, right, you guys know 1,000 grams is 1 kilogram, which gives us 0.1000 kilograms of water. Well, that gives us 0.217 mol. All right. That's how we do that. Now, once it's neat, because this is a low or a smaller concentration, right? The molality of 0.217 is close to the molarity of 0.215 because it's dilute. Now, as we get more and more grams of ethanol in the solution, they start to diverge, which is fun. But that is how we do number 8.